A few weeks ago, I had an exam on machine learning, and I was studying the day before, as you do, and I was reading the slides that the professor shared, but the first slide was about something called KNN, or K nearest neighbor, which got me wondering if I could do something with it. KNN is a machine learning algorithm, although it doesn't really learn. You just put in predetermined data and it uses that to predict future data. For example, let's say you have two features for your data, like maybe height and width, and you use these to determine if an object is wide or tall. So you know that an object here would be wide and one here would be tall. And then we introduce a new unknown object. What could it be? Well, just by looking at the object closest to it, we can see that it's most likely a wide one. This got me wondering, what if we use colors instead? So I made this. It's a simple program where you draw on the screen with colors, and it works its magic just like that. But what just happened? You likely noticed it, but here's what actually happens. So, we have the pixels already placed on the screen, then a new pixel is added to a random location, and it takes the color of the closest pixel. This one would be blue, and this one would be red. Then just do that again and again until the screen is filled. You can get some really cool results this way, using more colors and drawing different shapes. But that's that. That's called classification, as we classified the pixel's color by looking at the closest one. There's also this thing called regression, which is much more interesting. Regression in this case just means you get a real number instead of a categorized one. Think of it like birth. With classification, when the mom and dad really love each other, the kid is either going to just be the mom or the dad, depending on who's closer. But with regression, the kid would be more like mom plus dad over 2. Of course, with KNN, the K means how many neighbors it'll have, or in this case, how many parents. So if the neighbor count, or K, was 4, the family tree would be something like this, where the kid would be mom plus dad plus uncle plus aunt over 4. Crazy, right? It actually is crazy, which we'll see once we apply it here. So now, instead of seeing if this new pixel should be red or blue, we use the neighbors to calculate the color. Let's say K is 2, so we look for 2 neighbors. The neighbors here should be these, so let's get its color. We get this color simply by adding all of the neighbors' colors, dividing them by the neighbor count to get the average, which in this case would be little, giving us this beautiful color. Now, let's see what happens when we apply this to the entire thing. Pretty cool, huh? So that's basically the whole thing, but we can get some cooler results with more colors. Which is what inspired me to add this cool feature that lets you add a randomizing factor. You can see what kind of colors this will generate on the right. With this, you can get even more natural patterns such as camo or blood. I've also added some fantastic features such as drawing the entire thing in line so it looks like a CD under a microscope, or leaving some pixels blank for a cool effect. The resulting images are honestly a lot better than I expected, so I'm happy with it. Some cool things you can use this for is generating islands, clouds, camo, bullet holes, really disturbing imagery, terrain, or just messing around till you find something cool. Maybe it'll help you get inspired like it did for me. The next video I make will be in Turkish and about how I added a language support for my latest game. If it goes to plan, it'll be huge.